Let's look at what we were going to do today. So we talked a little bit about MVC. So we're going to revisit our quiz app. We're going to look at optionals. Another thing we're going to look at is the way that functions look is a little bit different in Swift than how they look in Java or in C++ or in JavaScript. So we'll spend a little bit of time there as well to explore that by itself. And then, so maybe in half an hour we'll have a break as well. Okay, so this is how we left the quiz app last week. So I went in and I added a couple of annotations to the app. So there's maybe a couple of more comments than we had before. But yeah, so let's just go through real quick in here what we've done, and then we'll continue. So again, yeah, we had our storyboard that we could access from this left tab here. We had plopped our components onto the storyboard, and then we were working on this view controller to wire things up. So what are we going to do next? So right now we had a lot of limitations with what this quiz app could do. So let's run it and let's see what was happening. Here we go. Where is it? It's booting. I'm going to get rid of, so for today, I'm going to get rid of the comments just to give us a little bit more space. They're there for you in the in what I had uploaded. Great. So our question was asked up here. We had our input field. So Carl the answer is fog. Reference to the Twitter account Carl the Fog. Very funny if you are not aware. So that was correct. We pressed this button, and the label up here, down here, showed us that we were correct. And that was pretty much it. So we had one question that we could ask ourselves, and the only other result that we could get here is if we type something else in, we had a response that we were incorrect here. So what are we going to do next? So we are going to introduce methods for how we can go through a set of questions, and we're going to try to do it in this new way of thinking about our app architecture. We're going to try to think of it as fitting into the MVC architecture. So let's tackle this. So the first thing, so we were doing a couple of things in this view controller that are not necessarily the responsibility of the view controller. So the view controller is there to lay out the model for to take the model and create a representation of the model and display it on the view. So we were storing some strings on the view controller here, and then we were checking whether or not our answer was correct. We were doing that also in our view controller. So there's a couple of red flags here that our view controller had too many responsibilities. So the responsibility of the view controller is pretty simple. It is to take whatever the model is, and we haven't really talked about what a model is. So it's supposed to take something and display it on the view. And then, so what is the view's responsibility? So the view controller's responsibility is to display the model onto the view. What is the view's responsibility? So it doesn't, yeah?
I would assume just to change the screens on certain actions.
Yes, yeah. So it's fairly simple. So there's very little logic, or there's not really a way for us right now to add logic into the view, because all of the view lives in this interface builder file here. So we can't really put any logic inside the view. So the view's responsibility is to display something. So that yeah, it's there to serve as a display board for the view controller, and its responsibility is to let the view controller know that something has changed if the view controller is interested in this. So those are the responsibilities of the view of the view. So yeah, so then we're left with a couple of things that we don't know where to put right now. So so this part, for example, so the checking that the solution is correct, so that whatever we typed in, that it matches the solution. So there's some logic here that's not related to the view. So that's a telltale sign that this belongs in the model. So the model is there to do computations for us. It's there to interact with other models. So, for example, accessing a database. So that's the responsibility of the model. So the model can access other models, and through some way potentially also let the view controller know that something has changed. Again, not directly, through some means that we'll see a little bit later, not today. Yeah, so computation is something that the model is in charge of. So computation, so changing data, and then also holding the data. Storing the data associated with our computations, that's also the responsibility of the model. So holding data, mutating that data, changing it, doing computations on it, communicating with other models. So those are the responsibilities of the model. And then yeah, so often models can match physical things pretty well. So in our example, we're creating a quiz app. So if we're thinking through maybe physical objects that we are interacting with, if we're creating like a little quiz, let's think of you want to study for an exam, and you are creating flashcards for yourself. So that's going to be what we have in mind for creating this quiz app that we're doing right now. So you have a stack of flashcards, and so each card has a question on it, and then it has an answer on the back, and then we have some way of keeping score of if we did something right or not. So that's kind of how we're going to think about what we're going to build here next. So yeah, so let's the first thing we'll do is let's take the logic out of this button here, and let's take this data that we're storing inside the view controller. Let's take that out as well. So those are the responsibilities of the model. So who can think of I guess I said it already. So what is the physical object that will hold the prompt and the solution? A flashcard, yes. So let's create a model. That's going to be our first model. We can just call it flashcard. So I think I can give us a little bit more screen real estate by hiding that left bar. We don't need the console right now, and then I can crank up the text a little bit so that we have a little bit more space here. Okay, so our first model is going to be our flashcard. One thing that is maybe different from what we've seen so far, our view controller had the keyword class in front of it, and now we're using the keyword struct. So in Swift, who has worked with classes and structs in previous courses? So who has worked with classes in previous courses? So theoretically, everyone's hand should go up because in Java, Java is an object-oriented programming language, and you should have taken some Java class already, course already. So yeah, you've seen classes in Java. I believe most of you should also have taken a C++ class. Is that correct? So in C++, you've seen structs. What were structs in C++? Who can give me a little bit of a summary of what structs were in C++? Yeah.
A collection of different variables.
A collection of different variables. So that fits that fits this right now. So we have a collection of variables. So that's great. So we have a collection of variables. that fits our definition of a struct in C++. So structs in Swift are way more powerful. So we are not limited to putting variables into a struct. Our struct can look like what a class would look like in Java or in C++. So we can have functions on there, so we can have functions and data in our structs. So you might wonder why is there this distinction? Why even create? So why is not everything a class? Why is not everything a struct? So I'll mention it right now. We'll come back to it later. It has to do with how we're passing around data. So a struct is a value type. Who has heard the term value type before? So other value types are int. A string is a value type in Swift. A double is a value type in Swift. Bool is a value type. So these are all value types. So string is a little bit different. So let's take string out for now. So let's look at int, double, and bool, and think C++ now. So an int, a double, and a bool. If we were passing them around, what was special about those? Say it again.
It's a primitive.
It's a primitive type. So what happens if I pass it into a function? What happens to it? Say it again. Pass by value. Yes. So what I'm passing an integer into a function. I'm making a copy of that integer. So I'm passing 5 into a function. The object 5 that I was working with is now a different one inside this function. So if I were to modify that variable, it's not changed on the outside. So value types are passed by value. So if I'm passing them, the entire object is being copied. So structs in Swift are value types. So if I want to create something that I want to be copied, the entire thing I want to be copied, I'm going to create a struct. So we now know pass by value. What is the opposite of pass by value? Pass by reference. So pass by reference. What does it mean if I pass something by reference? Let's say I have a student class right now. So I'm passing in a student class, and I'm changing the student's age inside this function. So I'm passing a student, an instance of a student into a function, and inside I'm changing the student's age. What happens to the student on the outside?
It'll change.
It'll also change. So let's say we're creating a student struct, and we're passing it into the function. So in Swift we can do this, and I'm changing the age of the student. What happens to the student on the outside? It does not update. So because it's a value type, if it's a struct, if I'm passing in a struct, the entire thing gets copied. So if I want to have access to it at the end, I have to pass it. I have to return it. So yeah, structs are value types. They're passed by reference, passed by value. Classes are reference types, and they're passed by reference. So I'm mentioning it right now. We'll see it later. We'll play around with it a little bit later. But so a big distinction. The big distinction is structs are value types. The entire thing is copied. So if I create an instance of a flashcard and I pass it into a function, the entire thing is copied. Okay. So why am I creating a struct here? So one of Apple's suggestions is whenever you can, create a struct for your data, for your models. If you're creating some sort of representation of data, if you can, create a struct. Why? Let's try to figure out why this might be beneficial. Why is it easier for us as a programmer if we're dealing with value types?
We can accidentally change it.
Say it again.
We cannot accidentally change it.
We cannot make accidental changes. Yes. Who can think of other?
We could also use it as a template.
What do you mean by use it as a template?
We could create some prototype of a certain
Ah,
structure and then
okay.
pass it to certain function that would fill it with certain values.
So, so there's a different thing in Swift for that. So there's a protocol which creates just the structure, and the implementation is different. We'll see protocols a little bit later, if I'm understanding your question correctly. Yeah. So we'll see protocols later. So we had. I can't accidentally change something inside a method. If I'm passing in a student and I'm changing something there, I have to be very explicit that I want something to update, and I have to return the student from this method. So yeah, accidental changes is one big reason why working with value types is a good thing whenever you can. Who can think of another reason? So let's I'll start writing. So benefits of using structs. And again, so you'll have this. You don't have to necessarily write it down. If it helps you remember, write it down. But you'll have access to this document. I'll upload it to iLearn. So structs are value types.
You can reuse it.
They are passed by value copied. Say it again, sorry.
You can reuse it.
You can reuse it. What do you mean by that?
You can use it in different classes.
So if I'm understanding your question correctly, I think you're going in a similar direction where you were going with. So you create like a structure, and then you can reuse it in different ways. So I think if I'm understanding your question correctly, that would be a protocol in Swift. So I'll give a little bit more of a scenario. Maybe you can figure out a couple of other helpful things when you're working with value types. So let's go through something that happens a lot when you're working with an app on the phone. So most apps, they're really boring unless you access the internet, right? So if you're and a lot of value is gained by we want to look at the bus schedule for when the next bus comes. If I just store it on the phone, maybe there's a change, and I don't know about it. So a lot of apps, pretty much most apps, at some point are going to talk to the internet. To be able to so on the order of magnitude of how long it takes to talk to the internet. So let's think: access something in memory, access something on disk, access something on the internet. Which of those takes the longest? The internet, yes. It's orders of magnitude longer. So depending on your connection, I'm making a request to the internet. It might take 30 seconds for me to get a response back. So to be able to make requests to the internet and still have a fluid user experience, we have to do some multitasking. So we want to have the UI work at the same time. We want to be able to update the UI at the same time as we're making requests to the internet, as we're doing an expensive computation. So we're going to be doing things at the same time. Any programming that you do that has a user interface, you're going to be working with concurrency. You're going to be working with threads. So things are happening at the same time. So if you're working in this kind of environment, which we are going to be, we don't really want to think about that a lot, because managing concurrency is a very hard thing. So we, as much as possible, we don't want to have to think about what might some other thing be doing at the same time as I'm doing something. So with that in mind, maybe think think through scenarios. Why might it be helpful to be dealing with value types in this scenario? Yes?
Probably to avoid the race conditions.
So the keyword, one of the big keywords here is race conditions. So who has heard the word race condition before? Great. So yeah, there's some funny examples for how to see what a race condition is. A funny one, I think, is the problem of you're using the last piece of milk. You're going to return it. You're going to go buy some milk, and your roommate also sees that there's no milk. If you don't communicate, you're going to end up with 2 pieces of milk. So you have a race condition. So you open the fridge. Oh, there's no milk. I close the fridge. I'm going to go buy some milk. Your roommate opens the door to the fridge. Oh, there's no milk. I'm going to go buy some milk, and you end up with 2 pieces of milk. Or I mean, so in application development, you'll end up with maybe a mixture of the milks, or just one milk, and some weird stuff happens when you work with concurrency. So by working with value types, let's go with a student again. Let's say I'm fetching a student from the internet, and at the same time I'm making an edit to an instance of a student, and now the student that I fetched from the internet comes back, but I had already edited something. What do I do now? So depending on when something comes back, when something happens, we have potentially a scenario where we don't really know what to do. So having immutable data, so value types, something that cannot be changed, is very helpful in this. So we'll see that a little bit later. So if a lot of that didn't make that much sense, or was just a lot of words, the one thing I want you to take away is, if you can work with structs, it's helpful to work with structs, and Apple suggests that you do work with structs. There are some downsides to it. One of them being you have to make a copy whenever you are working with when you're passing it around. So that is a downside. Most of the time, that is not going to matter with these powerful computers that we have in our pocket. So in your C++ class, I think you were optimizing that we're going to try to do as little extra work as possible. So for most scenarios, we're not really constrained by that as much. So I'll give a couple of other examples later. Anyway, so a little bit of a tangent here. So there's a difference between class and struct. So a struct is a value type. A class is passed by reference. Great. So yeah, whenever possible, we're going to try to create models that are structs. So yeah, big tangent. What is the responsibility of the model? It is going to hold data, and it is going to manipulate that data. So the data that we were holding in the view controller right now was the prompt and the solution, and the manipulation of the data, or some logic on the data that we were doing, was this button pressed. On button pressed, we were checking whether or not the solution was correct. So we're going to try to move both of these pieces out of the view controller and have that be the responsibility of the model. So again, the view controller's responsibility is to represent the model on the screen, and to react to changes on the screen, and to react to changes on the model. So yeah, so main responsibility of the view controller is display the model, not to do comparisons of strings. So that's a good indication that we're doing something that we're not supposed to be doing in a view controller. All right, so the simplest thing to do here is, let's just move the prompt and the solution out of the view controller, and let's move it into our flashcard model. So let's see what happens if we try to build this, and let's try to fix all the errors as we go. So yeah, I moved the prompt and the solution. So now as I'm trying to when the view had loaded, the first thing we were doing was we were displaying the prompt in our label. So this is not working anymore. Yeah, how do we access our model? So our view controller is going to have to know about the model. So let's create and as I was mentioning before, the view controller has full knowledge of the model, and it can own the model in this example. So card, flashcard. Oh. Okay, so we have a card now in our view controller. So far we're allowed to do this. Our view controller owns the model, and now we're going to try to display the model in our method that gets called after the view gets loaded. So instead of displaying the prompt, we're going to display the cards prompt. So card.prompt, and then let's just make this error go away. So instead of comparing it to the solution that we were storing on the view controller, let's compare it to the solution that was stored on the card. Okay, so this should still build. And so this should also still work. Great. Okay, so let's just take a quick break here. We'll continue in 10 minutes. And then, yeah, so things that we'll be doing is we'll separate the logic from the view controller. We'll move it into the model. We're going to introduce some other kind of model that will be able to manage multiple cards and display those. And so two other things that we'll explore are, so as you can see here, functions look kind of funky in Swift. So there's this underscore here. So there's something weird going on. We're going to explore what's going on there. And then we're going to explore optionals. Little teaser here. So an exclamation point is at the end of a type is an indication that we're dealing with an optional. So we'll explore what optionals are and when we're using them. So yeah, let's take 5 to 10 minutes, and then yeah. So I think there's add codes and maybe some other questions. I'll answer those right now.